Alright, hey guys, this is our last instructional video of the year. It's kind of crazy, and I'm going to try to teach you a whole lot in one short video. Normally this is a very inquiry-based unit that I do with my students, and it sticks in their heads. I'm going to try to give you the gist, the web quest that I gave you, and the moon observations, and some of the questions I've been asking you. We're going to try to put them all together. So if you've been following along, you'll still get something out of this, hopefully. Anyways, you guys went out, you observed the moon, and the first night I told you to go out and look at it. I want to say that it was a waxing gibbous. It was meaning it was past the first quarter moon, or the one that appears halfway illuminated. So it grew and grew and grew every night till it reached a full moon. And the full moon was coming out later than the previous moons. And then all of a sudden you guys couldn't see it at night, because every night it's coming out later and later and later until ultimately you started seeing it out in the morning. And then it was gone altogether. So we're going to pretend you guys are the sun. So if you're looking at Earth right now, everything you can see is daytime. Everything you can't see is nighttime. Another weird thing, what season are you representing? Well, I should make this easier on you and turn this around. If you guys see that axis, that tilt, that was a big thing from your web quest, and we'll talk about that in a second. Anyways, that tilt right now, we're in the beginning of June, is almost directly facing you, the sun. In any case, our moon is going around us. What you also noticed was we saw the same things. So like this little crater right here, that, I don't know, mud stain right there, was always in the middle of the moon. So if we're on the moon or Earth and this is going around us, it was always facing the Earth. And I don't know if you guys can see what I'm doing with the golf ball as I move it around the Earth, but the whole reason that it faces the Earth is because it is rotating once with every revolution. It has the same exact speed. This allows the actual face of the moon that we see to always be facing us. If it wasn't rotating, we would see all ends. So there is no dark side of the moon. That's total garbage, because I'm going to do it again and you're going to see all of the golf ball. Or I'm sorry, from your side you will only see none of the golf ball, but on the Earth they will be seeing all of the golf ball. In any case, right now you're in summer, it's tilted towards you. You guys also noticed, so it was getting out later and later and later. What's happening is this. The Earth is spinning counterclockwise. And you could figure this all out from looking at a globe, and this is one of the things that we'll talk about, or sorry, no we won't. But anyways, I wanted you to look at globes and get all of this. Here we are, New York. We know that the sun, okay, rises in the east, sets in the west, and that's because you're the sun. So if we start in the east and we go west to California, now you're facing California. Time just went by, about 3 hours, and the whole day goes by and we continue to spin counterclockwise. That represents daylight. As that happens, what's happening is the Earth is actually moving this way. And you can't see me now because I'm out of your camera lens, but I am walking around the perch that this is on. And I'm coming back into your picture now, and it's still on its same tilt. Okay? And as I move away, now I'm getting into the fall, and now I'm, oh my goodness, you're shining at the South Pole, but you can't see that because you're angled towards my road. Now it's spring, June 21st, pointed right at you. Anyways, seasons, we'll talk about that a little bit more in a second. Moon, back to the moon. We know that this doesn't glow. What's happening is you're shining your light on it. And if I turned my flashlight on, it wouldn't make much of a difference, because guess what? The sun is still out, which means that somewhere on the half of the Earth you can see is where we are. And this right here would be noon. New Canaan is right behind that tilt, okay? It would be highest in the sky. I'm shooting this video around 6 o'clock at night. We're gonna be right about there. You can still see me. However, as this continues to tilt, it will get dark, and then I would be able to use that camera light to project onto this golf ball. Now imagine the side you can see is always the illuminated side. As it goes here, you see the illuminated side, but yet nobody from Earth can see the side that's illuminated. This would be a new moon. When it gets to right here, okay, half of the moon that you still see, you always see the moon from you. You're projecting sunlight on it. You're always projecting light on it. Anyways, it would come to right here, and we would only see the right side of it illuminated, which would be a waxing, first quarter moon, and it's a waxing. As it gets to right here, more of it is visible from Earth, and right here, this is a full moon. However, if I was to go, say, down here, you can't see it, therefore it's not getting any light, and we would see a lunar eclipse because the moon is being eclipsed. Anyways, it orbits on a 5-degree plane going up and down, and in various seasons, it actually gets behind the Earth. And that just happened recently, which is another reason why you guys were saying that, oh, the moon actually looks brighter this month. We had a partial eclipse because what was happening is this was getting closer to in line with the sun and the Earth while it was approaching the full moon. Therefore, it was reflecting its light better back at the Earth than, say, if it was all the way up here. It's not really hitting it at the right angles, okay? It needs to be right there. That makes it brighter. Anyways, that 5-degree plane gives us eclipses. Solar eclipse, lunar eclipse. Full moon, lunar eclipse. New moon, solar eclipse. Waxing, waning. Waxing crescent, first quarter moon. Waxing gibbous, full moon. Waning gibbous, third quarter moon. Waning crescent, new moon. It takes 28 days to do that, and it rotates once every 28 days as well. So it takes 7 days to get to the first quarter, 14 days to get to the full moon, 21 days to the third quarter, and 28/day 0 at the new moon. Moon phases, done, capiche. Now, back to seasons. I've been telling you guys to get outside and catch some sun. Now, when you go outside, and I've been getting outside, if you can tell, and get some sun, if I'm standing like this, and the sun, well, it's never directly above us, and we'll get to that. The sun is actually, now you're no longer the sun. Let's say the sun is over there, okay? If I'm standing like this, it's coming down. Yeah, I should do this from a side view. It's over there. And it's coming down, and it's kind of hitting me like this and bouncing off. However, if I angle myself perfectly with that, so I make a right angle, those particles, those wavelengths, those photons smash into me. Okay, they make a direct hit, almost like when you drop, say, a golf ball. And it goes straight down, versus when you throw one, it skips over the air molecules. All of the energy is directly being transferred. Picture two cars. The two cars, and I gave you guys this example. Heck, I should show you these two cars. All right, there's my car, the little rinky-dink one with the good gas mileage, because I got to drive forever. And there's my wife's tank, the 4Runner. Okay, so car A, car B. Tank starts driving along, that car starts driving along. When they hit, sure, that would suck for me, I'm in that car. If they hit right at the bumpers though, right on the corners of the bumpers, I would actually kind of be spared, because we would end up going this way. Okay? We're not going to go, and that car isn't going to transfer all of its energy into me. We're going to combine our energies, and they're going to go this way. So in other words, it's not going to impact me that much. However, if I drove up the driveway and just went straight into that car as it's driving at me, well, there's going to be a lot more energy transfer. So this is what's correlating with the sun and how to get a sweet suntan and things like that. if you angle yourself at it, you're gonna get that sun, and you're gonna get it more directly. Those photons are gonna smash into you, and you're gonna get that more direct sunlight. Now, I'm sure you guys have had, say, sunburns on your shoulders and everything like that, and that's because maybe you're outside and you got either your bathing suit top on, or you're playing volleyball and guys got their shirts off. Anyways, the sun is coming right down on your shoulders, and that gets cooked. And if you got your back to the sun, it's getting cooked. It's just that it's hitting it more directly, and this is going to correlate perfectly with why we have seasons. So when it comes to seasons, well, the sun is shooting off its wavelengths, its photons, and they come in these little waves, and then they smash into the earth. The earth is essentially getting a tan. You guys were going to do that web quest, and when you did that web quest, you had a sun and you had an earth. Now, obviously, if I was going to do this to scale, and I love how all the traffic is going down right now, but whatever. Anyways, if you were going to do this to scale, I'd have to probably go all the way in that guy's backyard, and still wouldn't even be close. This would actually have to be about a mile away from me. So, we got these two. Mini scales, we're moving them in, scale is off, get with it, deal with it. Right now, we are tilted towards the sun, okay? So we're tilted towards the sun, and as we revolve, we stay on that tilt. We are coming from right here. We revolve counterclockwise. This would be the spring, summer, fall. We go on that side. We go on that side, and if you notice, the northern hemisphere is tilted away. Now, if I was going to really have you do this, I would have had you stare at the globe, and I would have had you look at these lines. The Tropic of Cancer, the Tropic of Capricorn, and the equator. Okay? So, right here, this one, guess what? Tilt of the Earth, 23.5 degrees. Tropic of Cancer, 23.5 degrees north latitude. Equator, 0. Tropic of Capricorn, 23.5 degrees south latitude. All of that is because they're called the tropics. The tropics are the only place in the world that at some point or another, twice a year, get direct sunlight. Except for the Tropic of Cancer and Tropic of Capricorn, they only get it once a year. That one day, June 21st, essentially Tropic of Cancer, the first day of summer, okay? And December 21st, the first day of winter, Tropic of Capricorn gets that direct sunlight. Anyways, the Earth is getting a tan. All those particles, just like I just said, where you angle towards the sun to get the best tan, well, when we're angled towards the sun, we're getting the best tan. Summer, it's hot. On top of that, we get our longest days and longest nights. Now, when it comes to that, the further north you go, it actually has longer daylight. If you think about Alaska in certain areas, only the ones, I'm going to go to Alaska, there it is, only the ones, so Fairbanks, guess what? They technically don't get 24 hours of sunlight, nor do they get 24 hours of darkness. They're just below what's called the Arctic Circle. The Arctic Circle is at 66.5 degrees north latitude. And if you think about that, the North Pole is 90 degrees. 90 minus 23.5 is 66.5. So everything in that Arctic Circle, that little dotted line at the top of the globe, right there, in summer, will get 24 hours of daylight, and in winter, 24 hours of darkness. Now, obviously, the same can be said for the Antarctic Circle down here, 66.5 south. So in their summer, 24 hours of sunlight. So December 21st, these guys are getting, actually the North Pole on December 21st is getting 24 hours of darkness, and they continue to get darkness, or I'm sorry, sunlight for a really long time. And on June 21st, okay, come June 21st, the Antarctic Circle at 66.5 doesn't get light, which means that everything below it hasn't been getting light for a really long time. This means that they've been in months of darkness. That's what's going on. More direct sunlight is what's causing the seasons. It's why you get a sweet tan. If you're angled right at it, you're gonna get all of those photons smashing into you. That is going to heat the earth. That is why we have seasons. It's not a matter of if you're the sun again and I'm the earth. It's not like all of a sudden this is winter and this is summer. In actuality, what's going on is in the northern hemisphere, we're actually even further away in our summer, okay? Further away in our summer, so this would be summer. And then as it revolves, and now all of a sudden it's facing the southern hemisphere, it's actually even closer. It's not a perfect circle. It's somewhat elliptical. And it's not perfectly centered around the sun either. Anyways, day, night is caused by rotation. Seasons are caused by revolution. On this tilt, 23.5 is the big deal. That is going to be impacting who is getting the direct sunlight, because as this moves, different areas, okay, are going to be getting the direct sunlight. Okay, first day of fall, hitting the equator. First day of spring, hitting the equator. Equinox, equal amounts of daylight. That means 12 hours of daylight, 12 hours of darkness on your first day of spring, which is March 21st roughly, and your first day of fall, which is September 21st roughly, and that's an equinox because the sun is hitting right in the middle at the equator. Go figure. Anyways, sorry that got a lot longer than I wanted to, but man, there's a whole lot that you can figure out from looking at a globe, and including like the way it rotates. Got moon phases in there, whole lot of information. Sorry about that. Hope you guys get something from this.